Okay, so in chapter 8, we're moving on to talk about polynomials. So we'll talk about what they are in just a minute, and a lot of what we're talking about here really stems from other things we've talked about, involving like terms and some of the exponent things from chapter 7. So a lot of this may not seem all that new to you. Okay, some of the things at the end with the division probably will, and some with multiplication. But otherwise the beginning part will probably seem pretty familiar to you. So a polynomial is an expression that is made up of adding and subtracting different terms. Okay, so let's just write a couple of things here. So a term could be made up of, I'm going to say it's a product of numbers and or variables. Okay, so product means it's multiplying. So it's things like 5x or negative 16x to the fourth or just x or just 5. Okay, those are all terms. And then my polynomial is the sum or difference of any number of terms. Okay, so we do use some different vocabulary. If it's a binomial, it has 2 terms. If it's a trinomial, it has 3 terms. If it's a monomial, it has 1 term. Other than that, we just call them polynomials. If something has 5 terms, there's no specific name for that. We just call it a polynomial. Okay, so when we want to add and subtract polynomials, okay, we're going to only add and subtract like terms. And if 2 things are going to be like terms, before we talked about this, we mainly just talked about, x's and y's being different. But in this case, like terms are going to have the same variables raised to the same powers. So in other words, x and x squared are not like terms. Okay, x and x squared are not like terms. So they have to have the same variable and the same power or exponent. When I add or subtract, exponents do not change. We'll worry about the subtraction in just a minute. So let's look at these two. First, example 1 and 2, they're not even written like 2 separate polynomials. It's just a whole bunch of terms that we're adding and subtracting here that we're simplifying. So we're going to look for like terms. I'm going to use some colors just to help us with that. And we're going to add or subtract like terms, remembering that the sign goes with the term it's right in front of. So I have 5x, oops, forgot I was on that one. Let's go back to the highlighter. 5x cubed, and a like term with that is going to be negative 3x cubed, so that negative goes with it. And then if I'm looking for other like terms, I have 2x, so positive 2x. If I look through here, here's another x term. I have an x to the fourth. Well, there's no other x to the fourth, so that's not going to be combined with anything. I have a 5x squared, positive 5x squared. That also won't be combined with anything. And then I have a positive 2. Okay, so I can see that I have a couple of pairs of like terms, and then the rest of them they do not have a like term with them. So let's go ahead and write and combine the like terms first. So I have 5x cubed minus 3x cubed. Well, 5 minus 3 is 2, so I just have 2x cubed. And again, my exponents do not change. Okay, then I have 2x squared minus 7x squared. 2 minus 7 is minus, sorry, not x squared. Plus 2x minus 7x is minus 5x. And then the other ones are just going to come down because there's nothing to combine them with. So sometimes I also like to kind of check off the ones I've used so I remember. So I used both yellow ones to get my x to the third. I used both green ones to my x, and then I used this blue one for x to the fourth. I'm going to use this purple one for 5x squared, and then I'm going to use this lavender one, which is also plus 2. So watching those signs. Okay, now to put it in standard form, which is kind of how we want our answers, we're going to put our exponents from highest to lowest, okay? So I look and I first have x to the fourth, so I'm going to say x to the fourth. It's positive because it has that plus in front of it. Then positive, so plus 2x to the third, plus 5x squared, minus 5x, remember that has an exponent of 1, and then my plus 2 at the end, because essentially, if I'm going to write 2, I could say it's the same as 2x to the 0, right? It's the same thing. So this is now what I'm going to have for my final answer. I know I can't do anything more with it because there are no more like terms, right, that I can combine. Okay, let's look at the next one. And again, this could have, this could be two, we could start out with two polynomials in parentheses. If we're adding them, it doesn't matter. We could just take the parentheses out and it could look like this. So again, I'm just going to use the colors just for now to get used to it. So x to the fifth, I'm looking for two that have, let's do minus 6 here. So minus 6, and then I have a plus 2. Those are like terms. They're just plain old numbers. Then I have 2x to the fourth minus x to the fourth. And I have 5x squared minus 7x squared. So I have all my like terms here. So I'm going to have x to the fifth minus 6 plus 2 is minus 4. Plus 2x to the fourth minus 1x to the fourth. 2 minus 1 is just 1. And then my x to the seconds are going to end up being minus 2x squared. So again, if I put them in order from highest exponent to lowest, I have x to the fifth plus x to the fourth minus 2x squared minus 4. All right, now the next couple are using subtraction. So subtraction brings in an extra little bit of trickiness. So if we look here, we see that it says, make sure the subtraction gets distributed through the entire polynomial. Okay, so let's look at this one for a second. So I have 13x cubed minus 9x squared minus 7x plus 1. So that's my first polynomial, right? And then my second polynomial is, sorry, I had to make sure my recorder was still going. My second polynomial is minus 7x cubed plus 2x squared minus 5x plus 9. So I'm subtracting the second polynomial. I want to subtract this whole thing. So let me just show you first what we cannot do. So I'll say no here, right? So we can't just take away the parentheses and say, well, this is the same as this minus negative 7x cubed plus 2x squared minus 5x plus 9. Okay, why can't I do that? Well, in this case, I'm subtracting that negative 7x cubed like I should be, but I also want to subtract 2x squared, and I want to subtract negative 5x. And if I just take away the parentheses, this subtraction is not getting over to these other terms, okay? So I can't do that. I can't just take away the parentheses. I have one of two options I can do. I can either leave the parentheses and just remember to work through this subtraction sign in every case, okay? That's one thing I can do. Let's do that first, and then I'll show you also a second way we can do it. So if I remember this subtraction sign every time, I have 13x cubed minus negative 7x cubed. Well, minus a negative is like plus, so that's 13x cubed plus 7x cubed is going to be 20x cubed. And then I'm going to have negative 9x squared minus 2x squared. So it's not negative 9 plus 2. It's negative 9 minus 2. That's going to be negative 11x squared. And then I have negative 7x minus negative 5x. Again, negative 7 minus negative 5 is like negative 7 plus 5, which is minus 2x. And then finally, I have this plus 1 here minus positive 9. So 1 minus 9 is negative 8. Okay, so you see that I had to, in every case, I had to work through, travel through that subtraction sign to get to what I wanted to subtract. Okay, so we can't skip over it. Another option is that we can rewrite this, okay? We can rewrite it remembering that we can add the opposite whenever there is subtraction. So we rewrite the first polynomial exactly as it is. And then instead of subtracting, I'm going to add. And then instead of each of those terms, I'm going to have the opposite. So if I change this to addition, I'm going to change this to a positive, negative, positive, negative. So I'm going to have plus 7x cubed minus 2x squared plus 5x minus 9. Now I don't need my parentheses anymore because I've changed it to an addition problem, and I've taken care of that subtraction. I've taken it into account because subtracting a negative is going to be a positive. Subtracting a positive is going to be a minus, right? So I've taken that into account as I rewrite those. Now, again, I can just look for common, for like terms. So 13x cubed plus 7x cubed is going to be 20x cubed. Minus 9x squared minus 2x squared is going to be minus 11x squared. Negative 7x plus 5x is minus 2x. And 1 minus 9 is minus 8. So I get the same answer. So either one of those options work, whether you want to just work through the subtraction every time, or whether you want to change it to an addition, adding the opposite, so it's all rewritten as an addition problem like example 1 and 2. Okay, so now we have an example here that has 3 polynomials being combined. We're subtracting and then we're adding. Okay, so again, you can do one of two things. You could just think about, working through that subtraction in each case, or you can rewrite just this part if you wanted. When I have something that's like terms, I want to look in all 3 places. So go ahead and pause the video and try this one on your own. Okay, really give it a good try on your own, and then start the video up again, and we'll take a look at it together. Okay, so hopefully you paused the video, gave yourself a chance to look at it. So again, we want to look at all 3 of these. So I'm going to look for like terms. I have 9y squared. I see that there's a 4y squared here in the part that we're subtracting. There is no squared in the last polynomial. So I'm just going to combine these two. So 9y squared minus 4y squared is 5y squared. Minus 11y, I have a y term here and I have a y term here. Okay, so negative 11 minus negative 5, negative 11 plus 5 is minus 6. And then this is plus, right? So plus, actually, let me not write that, sorry. Let me write it over to the side so we don't get confused. Okay, so if I want to keep track of it, I have negative 11y plus 5y plus 11y. Okay, so I can think about this as negative 6y plus 11y is going to be positive 5y. You can also see that because these two are going to cancel out to 0, right? Okay, so then let's look at what I have next. So I have a positive 12, just a plain old number, a constant. So I'm going to look at all my constants, and then I'm going to think about what I'm doing with each one. So I'm just going to write it over here again. 12 minus negative 5 minus 14, or plus negative 14, either way. So we can, 12 minus negative 5 is like 12 plus 5. 12 plus 5 is 17. 17 minus 14 is going to be positive 3. Again, if you wanted to write this instead as plus negative 14, that also works. Either way, same thing. Okay, so now again, I look at this, I can't do anything else with it because all the exponents are different, the terms, so I can't combine anything else. But just make sure that you are really careful with dealing with that subtraction. Okay, let's move down now to multiplying. So multiplying polynomials. Every term in the first polynomial gets multiplied by every term in the second polynomial. Okay, this is really important. So we'll talk in a second about something that you might already remember that deals with that. So if I'm multiplying things, so let's say, just as an example, I'm multiplying 5x squared times 3x plus 2, okay? So this is my first polynomial. It happens to be a monomial, right? One term. We spell it like this. Doesn't really make a difference here in what we do, but just so we know, and this is called a binomial because it has two terms. Okay, so if we are multiplying these two and then these two, so if I want to think about what I'm doing, I'm multiplying these two terms. Think back to chapter 7, right? We did this. We have two exponential expressions here. They have like bases, so when I multiply them, I add the exponents. So I would multiply my coefficients. My coefficient is the number in front, and then I add the exponents. We know how to do that in chapter 7. We're just putting it into a larger context now. Okay, now from multiplying polynomials, you might remember that if we have something like this, set up like this, where it's two binomials, you might remember learning something called FOIL, okay? And FOIL stands for the first, the outer, the inner, and the last. And all it means is this: you're going to multiply the first term in each parentheses together, so the first by the first. Then imagine that these are like four little things sitting together, right? These two are on the inside, they're kind of squished, these two are on the outside. So the O means the outer pair, then the inner pair, and then the last in each polynomial, okay? That is just a little reminder of what I have highlighted in blue there, really. Just that every term in the first polynomial gets multiplied by every term in the second polynomial. And this little FOIL idea of first, outer, inner, last works when you have a binomial times a binomial. Okay, if you have a binomial times a trinomial or a monomial times a binomial, just it doesn't quite work because, like here, you know, there isn't an outer pair, right? So what I have in blue is just a more general idea of that same situation of saying that every term in the first polynomial gets multiplied by every term in the second polynomial. So here in my FOIL example, x got multiplied by x and -5. 2 got multiplied by x and -5. All right, so let's do a couple examples here. Let me just see how many examples I have. Okay. So go ahead and try example 5, okay? Let's do the first term together, and then I'd like you to try it on your own after that, and then you can pop back in and check your answer. So I'm going to get you started. This -4x, the whole thing is going to get multiplied by each of these four terms in the parentheses. In each case, I multiply the coefficients, and then I add the exponents. So -4 times the 1 that's there is -4. This has a 1 on it, right? So x to the first times x to the third. I add those exponents and get x to the fourth. Okay, go ahead and pause the video and try those other three multiplications, please. Okay, so we already multiplied -4x times x to the third. Now we're going to multiply -4x times 9x squared. So we get -36. X to the first times x to the second is x to the third. Then I'm going to multiply -4x times -7x plus 28 x squared. Then I'm going to multiply negative 4x times 11. I get minus 44x. All right, I've done all of the problem now. I've taken negative 4x, I've multiplied it by every single term in those parentheses, right? The things in the parentheses don't get multiplied by each other because they're being added or subtracted. In each case, I multiplied the coefficients, the numbers in front of the variable, and I added the exponents for the variables. Notice here it was negative 4x times 11. There's nothing to add to it. So 1 plus nothing is just 1. So I keep that x there. Okay? All right, let's look at the next one. Next one is one of those FOIL problems. So again, if I'm thinking about the process, 2x gets multiplied by 5x, 2x gets multiplied by 3, and then negative 3 gets multiplied by 5x, negative 3 gets multiplied by 3. So I get 2x times 5x is 10x squared. 2x times 3 is 6x. Negative 3 times 5x is negative 15x. Negative 3 times 3 is negative 9. Now in this case, I'm not quite done yet, right? Because if I look carefully, I see that I have two terms that are like terms. They can be combined. So I get 10x squared. 6 minus 15, or 6 is the same as 6 plus negative 15. Either way is going to be negative 9. So negative 9x minus 9. Now there are no like terms that I can combine. Okay, the next one is 3m plus 4 squared. That whole thing is squared. Now, here's what it is not, okay? It does not end up being 9m squared plus 16. And let's think about why someone might think that, right? They might say, well, I'm going to take 3m and square it, and then I'm going to take 4 and square it. And that seems reasonable. And what people may be thinking about is something like this with our product rule, right? Where you're going to kind of multiply this by every one of those exponents, and you would end up with this, but it would be multiplied, right? So that's not exactly what I have. When I have an addition in here, I can't just say, oh, I'm going to square this and square this. I have to think about squaring that whole expression. So remember this. Remember that squared means to multiply by itself. Okay, so 3m plus 4 squared means I'm taking 3m plus 4 and I'm multiplying it by itself. Okay, now I have this problem that's a FOIL problem. It's a multiplication problem. I now multiply 3m by both things in the second parentheses, and I multiply 4 by both things in the second parentheses. And I get 9m squared. 3m times 3m is 9m squared. If it helps you, put in your little ones here. Okay, now when you get to each part of this multiplication, it's fine if you have to kind of pause it and see where we got it from, right? I'm kind of going through the multiplication a little bit faster, but make sure you see where they come from. The 3m got multiplied by the 3m. Now the 3m is getting multiplied by 4. 3m times 4 is positive 12m. Then I have the same thing here. 4 times 3m is positive 12m. And finally, 4 times 4 is 16. Again, I see that I have like terms that can be combined here. Whether or not you have like terms that need to be combined in that last step is really just dependent on what terms are in your original expressions, okay? Whether you'll end up with the same variables in your answer or not, same powers on the variables. So I have now 9m squared plus 24m, okay? Now, let me just finish this, plus 16. Here's the tricky part sometimes for people, is that you're switching back and forth here from multiplication to addition. So I take 3m times 4, I multiply it, I get 12m. When I was multiplying 3m times 3m, my exponent changed. However, when I add 12m and 12m, my exponent does not change, right? When we add like terms, it stays the same. So notice that what changed here was I got the 3m times 3m to give me my 9m squared. I got the 4 times 4 to be 16, but in this wrong answer up here, I did not get those middle terms. So that's what the difference is. Okay, so moving on to number 8. It's similar, right? 2x minus 1 is cubed. Again, what that means is 2x minus 1 multiplied by itself 3 times. And the way we deal with multiplying more than one expression together is by taking 2 at a time, any 2 at a time. So let's first look at these two, okay? 2x times 2x is 4x squared. And then I have minus 2x minus 2x plus 1. So that's what I got with those two. Then I'm still going to multiply that by this last 2x minus 1. Okay, I'm just going to color code it so you kind of see. So these two, I took these two green ones and multiplied them and got what's in green. I still have that blue one. Now I'm going to rewrite this, so I'm going to put it up here. I'm going to choose to clean up this first answer by adding those like terms, or combining, I should say, those like terms. So I'm going to get 4x squared, negative 2 minus 2 more is negative 4x plus 1. So I'm going to take this times my 2x minus 1. So this is still what I got before. Here's my green answer. I just combined like terms, so I'd have fewer terms there. And then here's my third factor, that blue one. Okay, so now I have to multiply these. So now 4x squared, remember my rule, right? Every term in the first parentheses gets multiplied by every term in the second parentheses. So 4x squared gets multiplied by those. Negative 4x gets multiplied by those two. Positive 1 gets multiplied by those two. Every term in the first parentheses gets a chance to get multiplied by each term in the second parentheses. So 4x squared times 2x is 8x cubed. 4x squared times negative 1 is minus 4x squared. Negative 4x times 2x is negative 8x squared. Negative 4x times negative 1 is positive 4x. 1 times 2x is 2x. 1 times negative 1 is negative 1. So I would really, really suggest that you stop, rewind the video a little bit, and look at that again, okay? Pause it, see if you can get the same things, see where all of those terms came from. And it's not a surprise to me that I have 6 terms at this point, because I have 3 terms in green, 2 terms in blue. Each of those 3 has to get multiplied by both of those. 3 times 2 is going to be 6. So now I'm going to look for like terms. So I look here, 8x cubed, there's nothing else that's 8x cubed. Negative 4x squared, I do have another x squared. And then I have an x and an x. So I have 8x cubed minus 12x squared plus 6x minus 1. I am in standard form, meaning that my exponents go from highest to lowest. There's nothing else I can combine there. Okay. Example 9. So again, very similar to what we ended up with the last one, to binomial times a trinomial, just flipped in the other order this time. So my 8a to the 4th gets a turn to be multiplied by all 3 in the second, and then my negative 10 gets a chance to be multiplied by all 3 in the second. All right, so again, we're going to get 6 terms, and we'll have to wait and see if any of them can be combined at the end. Okay, so 8a to the 4th times 3a to the 6th is 24a to the 10th. 8a to the 4th times 2a to the 3rd is 16a to the 7th. 8a to the fourth times negative 4a. So 8 times negative 4 is negative 32, and then a to the fifth. So I've done the first three. Now I'm going to multiply negative 10. So negative 10 times 3 is negative 30, a to the sixth, minus 20, a to the third, plus 40a. Okay, so negative 30. Since this negative 10 does not have an a on it, the a's in the other terms do not change. Okay, so now I look, and when I look at this, I have a to the 10th, a to the 7th, a to the 5th, a to the 6th, a to the 3rd, a to the 1st. Just because of what I started out with and what I have for each of these variables, I did not end up with any like terms. Okay, the only thing I may want to do is if I look, I might want to switch these two, right, to put it in standard form so I can have my exponents from highest to lowest. So 24a to the 10th plus 16a to the 7th minus 30a to the 6th minus 32a to the 5th minus 20a to the 3rd plus 40a. So there's my long answer because none of those are like terms that can be combined. Okay, so I'm going to stop this video right here because moving on, we're going into dividing, and I want to kind of keep that together in another video. We're going to do 3 different kinds of dividing. So at this point, we're done with adding, subtracting, and multiplying, and then I'll do a second video for the rest.